Okay, this is going to be a tutorial series based around doing side-scroller movement and top-down movement, but using 3D assets. So for this is going to be both a C# and a Bolt tutorial, and I just wanted to start on the screen to talk about a few things. I recently updated to 2019.3.11 F1 and realized that Bolt and that version of Unity do not like one another. So for the duration of this tutorial series, I would stay on 2019.3.9 F1 just to be safe. And then I'll tell you if at any point that it rectifies the issue. So we're going to start by creating a new project. And the way you create a project based on the version you want is where it says new in the top right. Just click on the little drop down and it'll give you what version do you want to use to create this new project. We're going to choose 2019.3.9 F1. I'm going to make it a 3D project because I want to make my, even though it could be a 2D game or like a 2.5D side scroller or a top-down isometric game, I want to use the 3D project so that it makes no difference really which one you choose. You can switch between the two. Okay, I'm going to just call this, let's just call it character controller tutorial. You can call it whatever you want. We're just going to create it and we're just going to wait patiently while it installs it. It's going. This is all in real time, no editing. Sorry about this. Okay, we're almost there. There we go. We're now running. Just gonna make sure that I go to the default settings so we all the Unity looks the same for everyone. Sorry about that. Ooh. Okay, so we'll need to install Bolt. Like I said, we're going to do both a Bolt and a C# controller. So I'm just going to import my custom package Bolt over here. And I'm using Bolt _1 _4 _11 _net4. That is the version I'm using. Any older versions with 2019 will cause some problems. So always just make sure that after you purchase Bolt that you have the latest version of Bolt and download and just go make sure that they have it working. Now the reason I'm showing you the installation process is Unity is in the process of upgrading to a new input system. So the old input system has been shifted and Bolt needs to know where that system has been shifted to. So by default, if you install Bolt as it is, you're going to get issues getting your get access raw, that sort of thing. So we just need to click on next. I choose program and naming all the time. And now we're in the assembly options. Go all the way to the bottom. Click on the little plus to add a new assembly. We're going to search for, just type in input. You can have three options: input module, which is now, as far as I understand, the new one, and they moved the one that we've been working for years into input legacy module. So input legacy module. Click next, and just the rest of the stuff just generate like normal. We're almost there. Again, depending on the PC, depending on if you have a solid state driver or not, this can take a little while because essentially a Unity package is like a zip file. So it's unzipping like all that data into Unity, into the appropriate folders. Okay, so while we're waiting, this first video is going to be specifically talking about how I set up my base character controller, and we're going to just be doing straight up movements. So this is going to be a short video, and then the next one we're going to build on top of that. So now we have the Ludic folder. We're good to go. In the case like this, I just want to turn off the sky in the background of my viewport. So I'm going to click on this little drop down and just turn off skybox over there, just so that it doesn't. And I'm just going to right click and create a new 3D object, which is going to be my plane. It's going to be my floor. And now I want my character in a side scroller to move in the x-axis, which is side to side here. So I'm just going to make this object like 3 times bigger in the X and make it about 0.25 in the Z, just so that there's a little bit of a platform the character can move on. He won't be able to fall off unless that's the kind of controller you want to create. He's only going to be moving in the X, but we could have it set up so that he can move in the X and the Y. Just going to rename that to floor, just so that I have something set up. And before we start, let me close that. I'm just going to go to the camera, and I'm just going to move the camera up, just so that, like a typical side scroller, the floor is a little bit in the lower thirds. I'm going to put it somewhere over there. And I also want to just disable the skybox in the camera. I will replace it with my own image at a later stage. So I'm going to select the camera, go to the camera component on the right here in the inspector, and where it says clear flags, skybox, click on that and choose solid color. I'm just going to change it to a darker kind of gray so we can see everything on top of it. There we go. At this point, I'm going to save, but Unity always creates a sample scene, default scene file, so I'm going to select it. I'm going to rename this and just call this SideScroller, just so that at least it's named correctly. So I'm not confused, like what scene was I in? If I rename it, I know this is my scene that I'm working in. Okay, so I kind of think a little bit ahead when I'm creating my stuff. So I create a base object, essentially an empty game object that has all the code on it, that has the colliders, the rigid body, and all that stuff, because we're going to use rigid body physics to move the character around. That way, all I need to do is just switch out the model as a child. That way, you could have multiple characters using the same logic, moving around the scene and working without having to, every time you update, if you do it the other way around where you just grab the model and apply all that stuff to the model, it can get a little bit tedious as far as trying to figure out like what scripts, what settings have to be copied over and over. So I always start with by right-clicking 3D object and create empty. I like to make sure my empty is at 0, 0, 0. I also need to make sure my floor is at 0, that is. Okay, so this is going to be my player. So I'm going to rename this and call this player. And because we're doing 2, I'm just going to call this one player bolt. Okay, I'm going to go back to my 3D view, and you'll see there's nothing in this character. It's just an empty game object. So we need to do a few things. I'm going to add a collider. So let's start by adding a capsule collider. I'm going to go into my 2D mode so I can see it from the side view. Notice how the collider is kind of round because the height is 1 meter. So unless you're doing a child or a small character, 1 meter is really short. So just for this case, I'm going to go extreme. I'm going to make this character 2 meters tall. Or for those of you from countries that are talking about feet, so that's going to be he's going to be 6 foot, essentially, a little bit taller actually, probably about 6'3". So I'm making him this character really tall. I'm keeping the radius as it is. Now you'll see that this is where the ground plane is, where the middle of the character is. So if we look at it go back into 3D view, I want this character's capsule collider to be above the ground because I want to keep the origin or the pivot at the bottom where the feet are. So I just want to move this capsule collider. And the way you do that is in the capsule collider itself, you'll see that there's a center, X, Y, and Z, and I'm going to move it up in the Y. And the amount that I move it up in the Y is based on the actual height. So I'll take the height, divide it by 2, and that is the height it needs to go, because that's going to be the half height. So the character is 2 meters tall, so I'm going to move this collider up by 1 meter, which is half. There we go. Now it's above the ground. Now all we need to do here is, as you go, just save. Anything can happen. I'm going to add a rigid body. This is going to be a rigid body 3D. Even though we're making a 2D game, I'm going to be using 3D physics. Now we're going to use the gravity, and we're going to just change this collision detection from discrete. And for now, make it continuous. We can tweak. If we need more, let's say, iterations or power, we can just choose one of the more robust ones, which is continuous, dynamic, or speculative. So I'm just going to do continuous for now. If the character happens to fall through the floor, if he travels too fast or runs through a wall, we can adjust this later. Okay, so I'm going to leave everything as it is because I want to show you a problem later, but I want to show you how you fix it in future. If I fix it now, you're not going to be aware that that's what fixed it later on. Okay, now all we need to do is add like a temporary character to this controller. So I'm going to right click on the actual player bolt, go 3D object, and I'm just going to add might as well just add a capsule collider, shall we? And again, capsule colliders, the height is 2 meters, which means we need to offset this capsule collider. not the capsule itself, the actual entire object. So I'm going to move it up in the one by the in the Y so that it's above the ground, and I'm going to remove the collider from this object. We do not need two colliders, we just need one. Remove collider. There we go. Okay, so remove the collider, and this is because this is just cosmetic. We're just going to see that the collider that's outside is going to be controlling whether the character can go up and down stairs, fall through the floor, that thing. So this is just going to be the character itself. So I'm going to remove this, rename this capsule to player. Let's call it body. I will leave it like that for now. I would like to create a material just so that he's not the same color as the floor. So in the assets at the bottom of your project, right click, create folder, just call this materials. Go into the materials folder, right click, go create material, and we're just going to call this player bolt. You can just change the color for each of the characters. So I'm just going to change this color in the inspector on the right here from white to, let's make it a straight up red. There we go. I'm going to assign the red to the character, and that's our little player bolt guy. It's got the rigid body, it's got a capsule collider. All we need to do now is I'm just going to shift him, let's make it -1 in the X, just so that he's off center. And I'm going to go Control D when the character is selected and move this one to 1 so that they're equally apart, the same distance apart, and rename this one to code. We can just call it C#. There we go. So this is the player C#, this is the bolt one. We're just going to duplicate this material down here and call this one player C#. Change its color to the complementary color. We're just going to make it 255 in the green and apply that to, I think it's this one. Correct. Okay, so now that we have our two little characters here, now what's nice about this setup is it's simple. When it's time to bring in the actual model and the animations, we just switch out the player body. We delete that and we assign the actual model to this base object. We don't touch this base object unless we take changing just the height of the collider, just so that if the character is a little shorter or a little taller. Okay, so let's get one character moving and then we'll move to the other one. So let's start with the bolt. The bolt character now requires us to add a flow machine. And I'm just going to be adding, for now, I'm just going to be adding one variable to this object. So it's going to be player speed. It's going to be a float. And I think the player speed, I'm going to make it around 300. The reason it's so high is because I'm using time.delta time to control the consistency of the character's movement based on frame rate. So we're just creating this variable called player speed. And now we need to go and click new, because without clicking new, we don't actually have a script assigned to the flow machine. Remember, a flow machine is just a visualizer for the code that we're inserting into it. So I'm going to right click and create a new folder here. Let's call this script. I'm going to call this one player controller bolt. And now you'll see you can edit graph. I'm going to bring it from my other screen and drop it down here. I'm going to make this a little bit bigger, make that smaller. And this is what it looks like. Again, if you guys have ever coded or bolt in the past, a C# script in Unity comes with two pre-built methods when you start it. It's going to come with the start and the update. We do not need the start, but we do need the update. I'm going to need to open up my variables that you use with the bolt. There's the variables that's attached to this object are object variables. So we're going to want to create some graph variable. We want to create some different types of variables. So I'm going to go to window at the top, open up my variables window, click on the little where it says a variable tab and drag it here and just dock it next to the original flow graph machine. So now we have our graph object. If you click on object, you'll see my player speed is there, scene, app, and saved. These are just different ways to handle the variables and where to place them. Okay, so we need to create another variable so we can continue forward. And in the graph, because we don't want it accessible by the editor, we just want it to be built into our graph. Excuse my laptop, that's on a jet, it's taking off. So let's call this player input. So I want to create a variable that I'm going to store the player input into. This is going to be a float. So this variable, we're going to, every time we press the A key or the D key or the arrows or the left analog stick side to side, it's going to store the input and feed it into the movement. Now, when you're working with rigid bodies and physics and all that kind of stuff, and you probably have watched this in several other tutorials, is physics needs to be on the fixed update. So we're going to call our input in the update because we want to have instant feedback, whether we're going left, right, but we're going to actually move the object or the character around in the fixed update so that we can get reliable and consistent results with our physics objects. So as we progress through the tutorials, we're going to get bigger and bigger this code's going to get bigger and bigger. But for now, all I need to do is hold down Alt and drag the player input so that we get a set variable. Plug that directly into the update because we're going to be updating this value with whatever buttons we're pressing on the A key, D key, side arrows, and the left analog stick right to side to side. Okay, so how do we get the actual input? We simply right click, we type in input.get access, and we're going to now get access and get access raw. The major difference between the two is get access allows you to interpolate between 0 up to 1, so animate, for a lack of a better description. So it'll go 0, 0.1, 0.2, 0.3, and up to 1, and then the same in the opposite direction from 0 to -1. Get access raw, think of it as integers, or it's either 0, 1, or -1, but it does not go in between the values. So depending on what you need to do, you can switch these out based on if your character has this kind of like, if you want to hold the analog stick lightly and he can walk, and if you want to push it all the way to the right, he runs, then you're going to want to use get input.get access. But if your character is always running or standing still, then you can just use input.get access rule. So I'm just going to use this one because I'm not quite sure at this point whether I want idle, walking, and running. So I'm just going to use this one for now just to be safe. Now, where are we going to get this name? The reason I don't do get key down like a lot of other tutorials is I have to think about the fact that the last thing I want to do is go and change what the difference between get access, input.get access, and you could also just get a key down saying get when A is down, when D is down, is what if I change my mind about whether or not I want to use A and D to move side to side, or if I wanted to use, let's just say J and L. I would have to go into every part of my code where I used get key down and change that. Whereas with actions you can just change the values in the action and then it will feed into this. So I'm going to type in horizontal here, uppercase H, lowercase everything else, with a Z, not an S, horizontal. And I'll show you where I'm getting that now. Go to Edit, Project Settings, and go to Input, and you'll see that it looks like there's nothing on the right here. Just click on where it says Axes, and you'll see these are the preset Unity input actions. We got one for horizontal, which you see it repeats twice. The top one here is for my keyboard. The one at the bottom here is for my left analog stick. And same thing for here. My vertical is for my keyboard, and the vertical down here is for my analog stick. We also have fire, which this one is going to firing is using my left control or my left mouse button, and this fire down here is using my joystick button 0. So these are already pre-built presets of what people use most commonly, which is your left mouse button, right mouse button, middle mouse button, and then your mouse X movement, mouse Y movement, wheel mouse scrolling, enter. I think this one is your return value, and this is your enter. So this is all set up. So we're just using the horizontal, and if you look at the horizontal, it supports the left key arrow, right arrow, A key, and D key. And if you look down here, because I'm using horizontal, it also supports my left joystick on the X axis, which is side to side. So if I ever at any point decide to change the keys, I don't have to go and change the name. I just have to change the inputs down here, the keys themselves, and it will propagate through to all the code that I've used horizontal in. That is why we're using horizontal. So let me plug that into the variable so that we're updating it. And let me just show you what it does when we're playing. If you look down here on the screen, it says 0. If I go right, 1. If I let go, notice how it doesn't go 0, 1 straight up. It just actually interpolates and animates between those values. And if I go the opposite direction, I get -1. If I let go, 0, 1. So we know the input is working. Okay, so I'm just going to hold down Control, left click and drag around this and add a group just to keep track of what I'm doing. Just going to make this a little bit smaller, and we're going to call this one player input. That's what we're doing. Just even say it, player input on update. There we go. Now that we have that, we can now use the fixed update to do the physics. So we're going to right click and type in fixed update. Because remember, fixed update only happens, update happens every frame. A fixed update can happen, maybe we could even go say fixed update happen 12 times a frame, or happen every third frame, or happen every fourth frame. We can control this fixed update based on the timestamp. So if we go to edit, project settings, go to physics, where are you? I will find it. Is it under player? I will find it. Well, we'll come back to that, but you can change time. There we go. Under time, you have your fixed time step that's 0.02, and your time scale is 0.1, your maximum allowed. So you can play around with your time step to make it either go do less per frame or more. So that's where your fixed time step is. Okay, so let's do our fixed update. And what do we want to do on our fixed update? We want to drag out and type in rigid body dot velocity, and we're going to do set. So rigid body dot velocity set. We want to set the player's velocity. I'm going to maximize this window. If you wonder how you do it, maximize any window in Unity, just go Shift Spacebar. For those of you who are old school Blender users, this will make a lot of sense. So Shift Spacebar will maximize this window. You'll see my variables are no longer on the right here. When I maximize them, they're on the left. So if you're wondering, I'm just using the variables on the left if you haven't maximized your view yet. Okay, so I really only want to get access to the X movement. The Y movement I want gravity to control, and the Z movement I don't care about because I'm not moving the character in the Z. So I'm going to drag from the rigid body velocity vector 3 here and create a new vector 3 X, Y, Z. Like I said, we only need to worry about the X, so getting the Y working is really simple. You're going to type in rigid body again, dot velocity. If I could spell velocity. And this time we're getting the rigid body dot velocity. And you'll see that it's again, the output is a vector 3. We only care about the Y movement, the up and down. So we're going to drag out, we're going to type in vector 3.y, and it's going to be a get. So vector 3.y, and in the brackets it's going to be get, because all I care about is how the gravity is affecting the character up and down, which is the y-axis. I'm going to plug that directly into the y. Let's just move this down here. I'm going to put a little group around this and call this gravity while moving. Something like that. I guess it makes a little bit of sense. Not too much, but a little bit. Now we need to do the X. So the X is simple enough. We're going to grab our player input. We're going to go to the object variable, and we're going to grab our player speed. And we're going to multiply these two together. So we're going to go multiply. The reason we're multiplying, remember, whenever you get a value from the keyboard, the analog stick, it's always what we call a normalized value. It is between 0 and 1. So if you don't multiply this input by anything and you just drag it in and plug it into there, the character's not going to move very fast because the maximum speed he's going to be able to move is 1 unit. So we use this player speed to control the speed in the editor. So if you're artists or you are tweaking your player speed, all you need to do is just tweak that value and the character is going to run faster or slower. If you just plugged in the player input, that's it. It's 1, 0, or -1, and that's the fastest this character will run. Okay, so let's drag from the multiply and type in multiply one more time. And we're now going to multiply this by time.fixed delta time so that we can make sure that whether the game is running at 60, 30, or 120 frames a second, the character will always travel at the correct speed. So from the B, drag out and type in time.fixed delta time. Now you're probably wondering, why am I not just doing time dot delta time? I could. Unity is smart enough, or the Unity and C Sharp, that even if I used the wrong one here, it would still use fixed delta time because I'm running it in a fixed update. So, but just for good practice, because I'm putting it in the fixed update, I'm using fixed delta time. If I was putting this in the update, it would just be time dot delta time. Plug that into the X and let's see what happens. I'm just going to put a comment group around this. Just call this player speed input. There we go. And then over here, just in this section here, we're just going to put a comment group around this, and we just call this player velocity. Move these away from each other. They're really on top of each other. There we go. So let's test this out, see what happens. I'm just going to push this down here, push play. And now this is where you're going to see a weird thing. When I start moving, he is moving, but notice how he's falling over because he's trying to roll. Remember, physics, or at least using a capsule collider and using a rigid body physics, it's basically thinking of this object as what it is, this kind of capsule. So as I move it sideways, it falls over, and every time I add force, it tries to roll around as if you were trying to roll a ball around or an inanimate object that you're forcing it to move around. So we want to make sure we lock these movements. So I'm going to select both my bolt and my C sharp. I'm going to open up the rigid body, go to the constraints, and now you're going to know where to fix. If your character rolls or falls over, I'm going to freeze all of the rotations, X, Y, and Z. So the only way this character is going to fall over or roll or rotate is if I tell it to. So I'm telling it to not do any kind of rotation. Okay, left, right, he no longer falls over. If I stop, he stops moving. Left, right, there we go. That's it. That's the bolt section of this code done. So I'm just going to move over to the console project here, and now we're going to do the same thing in code. So I'm going to go to the scripts folder, right click, create C# script. I'm going to call this player controller code, and I'm going to show you how to assign the script once it's compiled. Select the character you want to, and you've got three ways. You can drag the script onto the object in the hierarchy. You can also just drag it across to the object you got selected into the inspector, like I just did there. Or you can just go and say add component and search for it. Those are the three ways that you can do. Depending on how many objects, I find that dragging it like this is easier, or sometimes across there. But if you have a lot of components, it can be tricky to just drag it across. So I'm going to remove all of them except for one. Okay, let's open up the script. There we go. Like we did, notice how there's a start and there's an update. So we don't need the start for now, so I'm just going to remove that. And we're going to add the three variables that we need. Notice how we have one extra, and I'll talk you through it. So I tend to like using serialized fields if it's not going to be a variable that I need to access from another script, because this will be accessible only in the editor and only in this script. But it's good I like to make a lot of the code that I use for artists who are tweaking stuff to serialized fields. So this one's going to be a float, and this one's going to be player speed. And remember, the player speed was set to 300 by default. So that's how you set a default value. You say the variable equals the following. And we're going to make another serialized field. This one's going to be of a rigid body. And this is where it's different. I'm just going to call this RB for short. Now, the reason that we didn't have to do bolt, add a rigid body to bolt, is bolt, as we set rigid body.velocity, says, where is this rigid body? And if you look just below that, it says self. So it's looking on the object that the script is on for the rigid body. Code doesn't do that. You need to specify to the code, where is this rigid body? So we're going to type in private for the last variable. It's also going to be a float, and this one's going to be player input. Remember, like we put the one in bolt, we put player input into the graph section of the variables. we're putting this private because we don't want this variable to be accessible by anyone but a programmer who will have to open up this code and access that. Okay, so remember in the update, all we did was type in player input is equal, and what is the player input equal to? Input dot get access, 2 round brackets. Notice how when I do that, you can see just below it's telling me what needs to be in these round brackets. The name of the action. So we're going to add, and whenever you see string, you always need to add 2 quotation marks, and we're going to type in horizontal in there, and then just a semicolon. And that's it. That's exactly what we did in Bolt. We said the player input is equal to input.getAccess horizontal. So now that we have that input, remember we went and added a fixed update. So you can have the word private. Notice how the update doesn't. So you could also remove that if it bugs you, or you can put private in front of update. It's just by default, if it doesn't have the word private in front of it, it's automatically private. Okay, so fixed update, what are we doing in the fixed update? We are basically saying RB, which is the rigid body. Remember the variable we created up here, dot velocity. Remember we said RB dot velocity is equal to, and what is it equal to? Remember we had a new vector 3, so we need to type in new vector 3. And if you hover over any variable and you're not quite sure what to do, just hit save. A vector 3 requires 3 inputs, x, y, and z. So the x, we know what it is. X is going to be player input multiplied by player speed multiplied by time dot fixed delta time. That is your x movement, comma, and what is the gravity? The up and down, it's going to be RB dot velocity, remember, and all we wanted to do was get the y-axis. And in the last one, like we did in Bolt, we just left it at 0 for the z. Okay, so let's talk this through. This first section from player input all the way down to here is just to get the character to move from side to side. So player input, which is 0, minus 1 through 1, multiplied by player speed, which is currently set to 300, and then multiply that by time dot fixed delta time so we can get movement that is independent of frame rate. And then the second one, which is y, which is this rb.velocity.y. All we're saying is, by the way, remember, you need to be influenced by gravity. And then the last one is, we don't care, make it 0. Okay, so let's save that. Let's go back to Unity. Let the code compile so you can see on the right here, we now have access to the speed. We have access to this rigid body. Notice how there is no rigid body, but if you look just above it, you'll see that we have a rigid body applied to this object. So all we need to do is left click on the rigid body, drag it, and drop it into the RB. Or you can just grab the object that the rigid body is attached to and drag it into there. Same thing. Okay, so let's test this out and see what happens. Both characters will not fall over. Remember, we've locked. There we go. We have movement left, right, left, right. They move exactly the same because remember, whether it's Bolt or C#, they're both built on the same language, which is C#. So they behave the exact same way because they've been coded the same way. There we go, and that's it for this video. We have movement. So next video, we're going to set up getting the character to rotate in the direction he's moving. And after we're done with that, we're just going to add jumping and then talk about Unity's jump physics as far as jumping and then how we need to tweak it to make it better. That's it. Thank you so much for watching, and I'll see you in the next video. Cheers, guys.